C++ operators such as the addition sign, the greater than or less than sign, the decrementer sign, and even the print operators may be redefined. This behavior is termed operator overloading. There may be scenarios where we want to extend how these operators behave to suit a specific context. Let's look at an example to demonstrate how to overload the decrement operator within a class. So I'm going to define a generic function class O class, and it has a private variable called count, int count, and it has a public set of functions. The first is the constructor, which initializes count to be whatever is passed in, count equals CNT. I'm going to define a print statement so that we can see what variables have been assigned to what values have been assigned to our variables. So cout count and line. And I'm going to overload the decrement operator. So void, because it's not going to return anything, the operator expression, then the operator sign that I care to overload, which is the decrementer operator, minus minus. And the function is not going to receive anything. I'm going to open it, and what it will do is when the decrementer operator is called, then the count variable is going to be decremented by 3. So let's see how that works. If we construct our object, O class object, and initialize it with the value 4, we can call our operator minus minus our object, and then so this will do that operator overloading operation, and I'm going to print to see what happened, to see whether my count variable did in fact get updated. So I passed in the variable 4, I called my decrementer, and it subtracted 3, which resulted in a final count value of 1. Now, this is not typically the way that we're used to seeing the decrementer operator. The way we've defined it, it specifically expects to be called first and then our object value. But if we wanted to use this kind of decrementer, which is probably what we're used to the most, where it appears after the object, then we can do a slight change in our operator function. So I'm going to call that and tell it to expect a integer value. So count is going to be updated by decrementing. Instead of 3, I'm going to do 5 so we can see that there is in fact a difference happening. And I'm going to call my print statement. So what we did just now was define what we call a postfix decrement operator. So this is a postfix decrement operator, and this is the prefix decrement operator. So if I call it again, 4 minus 3 was 1, and now with our postfix decrement operator, 1 minus 5 is minus 4, is negative 4. And if we just checked our initial or original standard decrement operator with I minus minus, we should see that that had no effect. So as in the global definition of the decrement operator was not overridden. It was only the decrement operator with respect to O class. So I and line. And so we see that I was decremented by 1. So this decrement operator, the global one, is independent of the one that we defined within our class object. This is a very useful feature because it allows us to customize how certain operators work to make it a little easier for developers of the code to write things in a more readable fashion. Almost any operator in C++ can be overloaded in such a way. There are some few exceptions, but almost all of them. So the plus sign, the minus operator, multiplication, modulus, greater than, less than, equal to. And in fact, behind the scenes, these are what operators are. They're effectively functions that receive variables and manipulate them and return a value. So hopefully this will make how operators are defined a little less mysterious.